I'm just going to show you how to make a web scraper that you can package in Docker and deploy to Lambda. This tutorial is going to be for people who have a bit of experience with Python, Lambda, and Docker, but aren't quite sure how to put all this stuff together. If you found this video useful, then I'd appreciate a like and subscribe to this channel. This is going to motivate me to make more videos, and I'd be open to some recommendations on what to make. If you found this video awful, then I'd appreciate some feedback on what I can do to make the next one better. Okay, I think that's the standard YouTube stuff out the way. Let's get into the project. Actually, before we start, some prerequisites for this project are that I'm going to assume you've got Python and Docker installed on your local machine, and that you've got an AWS account. If you've got all that, then follow me, and I'll quickly show you an example of the project running and what it actually does. So here we go. Let's head over to S3, where you can see I've got an empty bucket called MyDogsYouTube. I've got some permissions set to allow certain public access to the files, because who doesn't love free images, right? Getting that in there now, as I'll probably going to refer to that a bit later in the video. So now, let's going to head over to Lambda. And by the way, you'll notice I'm in Ireland, and that's the closest region to me that supports Docker containers for Lambda. So here you see an image scraper, and I can trigger my Lambda with a test event. Let me show you what's in there. So here you can see a query field, so it means we're going to query Google Images for golden retrievers. We've got a count, so we're going to get 3 images. I've got the bucket, and I'm going to specify to persist to MyDogsYouTube, the bucket I showed you before. And we've got folder path, which is an example folder. I'm going to head and run this. So you can see it looked like it all worked. You can see the success message that we loaded 3 images to our bucket. And in the particular folder path example, and you can see the image names, and they look a little bit random, and that's because the names are based on a hash of the image data. And now I'm going to show you the S3 bucket, because I know what you're thinking, that there's no proof that anything just worked yet. So here we are, MyDogsYouTube. But now it's not empty anymore, and you can see we've got a folder that we specified and the 3 images we specified to scrape. So let me show you one, and you can see it looks like a lot like a golden retriever to me. So now you see what we're going to build. Let's dive into the code. So here we are at long last, the code, and the repo is really split into 3 parts. There's the Python code that's going to be used for scraping the web and persisting those images, and that's stored here in the app package. And of course, we've got the Lambda function handler, which is in the app.py file. There's also the entry shell script that's going to be packaged into the Docker image. And what this is used for essentially is swapping the command that's going to be run depending on whether you're running this in a Docker container in Lambda or whether you're running it on your local machine. And then of course there's the Dockerfile itself, which is responsible for creating our Docker image that we're obviously eventually going to be deploying on Lambda. So before we do a deeper dive on the code, I'm actually going to pay homage to some of the resources I used and took inspiration from in order to make this project. So here on towarddataScience.com, there's a wonderful tutorial about image scraping with Python, and I basically followed this tutorial and modified it slightly for my purposes. So you know, if there's any bad code in this part of the project, it was this guy's fault, not mine. No, I'm just kidding. Good job, Fabian Bosler, who wrote this wonderful tutorial. And then there's this guy, Jairo Vidio, who made this repo called PyChromeless. And essentially what this guy's done is he's created this WebDriver wrapper, which has tuned a lot of the settings and the driver options for getting Python to use Chrome driver in a headless state, so it can be used on things like Lambda. Now onto the Python code. You can see here we're in the app.py file, and this is a Lambda function handler. So what it does is that we instantiate a scraper or image scraper object, and then this image scraper object is used to download those image URLs. And you see here we refer to event query and event count. And what we're referring to here is actually, if we go back to the Lambda test event, you'll remember that we passed through some data here, the query, which was golden retrievers, count, which was 3, the bucket, which was MyDogsYouTube, and the folder path, which was example. So let's go back to the code, and then you see that's what we've passed in there. So then we go onto the URLs, and what we do is from each URL we actually use the scraper to download the image data from that URL, and what we have here is what I refer to as image hash, and that's a hash name created based on the data of the image, so I can use that as a unique file name exactly. And so when we go to here, the S3 upload object, you see here we have the event bucket, which we referred to in the Lambda test event data, and the same thing with the folder path, and then using the image hash again as well. And then we're going to use the scraper to close the connection to the Chrome driver, and what you'll see here is we'll return a success message, and you can see all the things that all the data that we pass through essentially. So quickly, I'm just going to go through the two helper packages. The first one is AWS S3, and all this has is an upload object method, and that's because that's all I really needed. So you can see it takes an object of bytes, the bucket that we want to save it to, the key that we want to save the object as, the content type, so you can specify JPEG or a PNG, and then also the grant read permissions, which if you remember, I referred back to the fact that my bucket has some public permissions, and that's because for a particular purpose I wanted to have some read-only permissions available, so I can pass that through in this method as well. So again, here now we're in the image scraper file. I'm not going to talk too much about this because again, there's the wonderful tutorial by towarddata-science.com that explains how most of this works. The one thing that I did though was create this get in-memory image method, and so what it does is it downloads the image content from the URL, and then it opens that image as well as creating here the in-mem file as a stream of bytes, and then we save that image to the stream of bytes, which we then return to be uploaded to S3 along with the image hash as well. Now we're going to talk about the Dockerfile. The vast majority of this Dockerfile came from an AWS blog where this guy created your kind of hello world version of a container running Python code for Lambda, obviously. And I took it a bit further to create a web scraper, so now I'm just going to describe some of the main differences or additions to the file. You see here in stage 1, it's exactly the same. We're getting an Alpine image for Python, which is essentially a really slimmed down version of Linux. And this Alpine Linux distro doesn't have a GCC installed, which we need in order to install some of our dependencies. In stage 2, we're pretty much the same. We use our APK package manager to install a load of dependencies that are then required to install this Lambda runtime interface client, which you see here. And the client is essentially needed by your image to run a container in Lambda. One slight difference here is that they also copy their app package into this function directory we're creating, and I moved that command to much later in the build process. The reason for that is because whenever Docker builds an image, if it notices a change in a particular step, like say for instance it's noticed my app folder has a few new files in it, it will start a new build process from that step. All previous steps are sort of cached and they run quickly, but after a new change, all the following steps are done from scratch. So something that I expect to make changes to quite regularly, I kind of want to add right toward the end of the Dockerfile to prevent some of these kind of static non-changing steps from running from scratch and have those kind of cached, and that will keep my Docker build nice and fast essentially. Before I move on to stage 3, I want to quickly explain what these stages are. This Dockerfile is a multi-stage build process, and what that essentially means is that in each stage we're creating an image to potentially be used as a base for creating the next image or the next stage. And this is a Docker recommended best practice for building your images, especially as they grow and become quite complex. Stage 3 is the stage I sort of write on my own, and so we won't compare this to the blog stage 3, which is actually more comparable to my stage 4. You'll notice here I'm actually starting a new stage from Python Alpine, which is the name of our first stage image. And then you'll see here we're copying our function directory, which is where we download the runtime interface client, from build image, which was our second stage. So what this trick actually allows you to do is to have the runtime interface client installed, but you can leave the dependencies required to install it behind, and this helps keep your Docker image small in memory size. The second part of the stage 3 build is to install a load of dependencies that are required in order to be able to install the Python dependencies. You'll see here dependencies like JPEG dev, zlib dev are required in order to be able to install Pillow, which is a Python package I use for image manipulation. You'll then see I copy over my requirements txt and run pip install, installing the dependencies into my function directory. Moving on to stage 4, you'll notice that we start from Python Alpine again, keeping that image size small. We copy over the function directory from build image 2 this time, where the runtime interface client and our Python dependencies are installed. The eagle-eyed amongst you will notice that we're actually copying some of the same dependencies as we did in stage 3, and this is because Python, or Pillow in Python rather, actually needs these installed in order to run as well as be installed itself. But we have left some of them behind, which is good. We also then move on to installing our Chrome driver, which is essential in order to be able to scrape the web. We then move on to installing the runtime interface emulator, just like the blog does, and as explained before with the shell script, which helps us determine which command to run depending on whether the container is local or on Lambda. Also, as well, you see here I mentioned that I wanted to move the copying of my app directory, something that's going to change frequently, to as late as possible in the build stage, and here it is, pretty much the last thing in the process. Then the entry point and the command are copied directly over from the blog. And so that's the Dockerfile in all its glory. We're going to move on to running this thing locally and then eventually deploying it to Lambda. Okay, so we're going to build our Docker image first using the following command. The -t flag is used to tag our image to give it the name Lambda image scraper, and it's going to have a version number of 1.0, and then followed by a full stop at the end to specify the build context. Note that we're in our root directory of our project here. Okay, let's run it. And it looks like the build worked. Great. Okay, so we're going to run our container with the following command. -p exposing the port 9000 on our local machine, and then the -v flag to mount a volume. Here I'm mounting my AWS credentials into the running container, so the container has access to my account and therefore the S3 bucket. If you don't know what the .aws folder is, take a look at setting up AWS credentials for the AWS CLI. You see now that the container is now running, and I'm going to open a local, another terminal. And you see a curl command basically copied from that AWS container blog, which is used to invoke the Lambda function. And you see here I'm passing data similar to what was passed into the Lambda test event. So I'm going to run that. Great, it looked like it worked. So let's go over to S3 and let's reload the page. And we can see a new local folder from the local invocation we just did. And here are the pictures, and there's a picture of a beagle. Great. Now I'm going to show you how to get the container, or the image rather, onto AWS Lambda. Before using an image with Lambda, it needs to be stored on Amazon's Elastic Container Registry service. We need to set up a private repository, and I think there is a free tier about 500 megabytes a month, but do check if you fear being charged, as prices often change. Okay, let's create our ECR repo. I'm headed over to the docs, and the first thing we need to do is authenticate our Docker client with Amazon ECR. So I'm just going to copy this command. Oh, looks like it's already there. And remember to adjust the region and the account number as necessary. If successful, you should see a command like login succeeded. Now I'm going to create the repository. And here I'm going to change the region again, and I'm also going to change the repository name to Lambda image scraper, I think. Cool. Let's create that. Now I'm going to tag the image that I want to push to the repository. Again, I'm going to copy this command, and I'm going to substitute the account ID and the region as necessary, and also the tagged image as well. So here we're just putting the image that we've tagged, and we call that Lambda image scraper. Then we're going to, and the version number as well. And then we're going to change the account ID. Remember, you're just going to put your account ID here. And then we're going to change the region. I mean, I'm EU West 1, but you might want to use a different region that's closer to you. And then at the end here, we're going to change, instead of Hello World latest, we're going to put Lambda image scraper version 1. Great. That's successfully tagged. And now we're going to try and push to the repository. So we're going to copy this command. And again, change the region account number. Well, first let's change the tag. Now let's change the region. And lastly, the account number. This command's going to take a while. Okay, now let's check the repo on the console. Okay, sweet. We see the image here in the repo. Now let's get Lambda to use it. Actually, let's first pop over to IAM because we need a role for Lambda so that it has a S3 access. You see here, I've already created a role. It's called Scraper Execution Role, and you see here it has Amazon S3 full access and Amazon Basic Execution Role. You could make the S3 access a bit more granular, but it doesn't matter. Let's go to Lambda. Okay, and now let's create the function. I'm going to call mine image scraper. And then I'm going to find the image. Select that. Oh, and we need to change the role. So as I showed you before, it's the scraper execution role I'm going to use. Now let's create the function. Give that a second to load. Okay, cool. Looks like it's worked. I'm going to create a test event, just like I showed you at the start of the video. It's a query, and I think I'm going to pick Dalmatians. Then count. I'll get 3 images. Bucket, and it's my dog's YouTube. And then folder path. I'm going to call it new for new test event. Okay, let's create that. Now let's run it. Aha, you see it's failed here. So the reason is because the task timed out after 3 seconds. Now given that we're image scraping, it's going to take longer than 3 seconds to do what we need to do. So we need to make some adjustments in the Lambda. So let's go to the bottom. And here we see the basic settings, the timeout, or the memory as well is an issue. So I think I'm going to give it 512 megabytes of memory, and then I'm going to give it a minute to do what it needs to do. Save that. Now let's run the test event again. And this time it looks like it's worked. See here, successful message. And also, if we look at the memory as well, looks like we provisioned enough memory, so that was good. So let's go over to S3, and I'll show you the results of that invocation. And so here now we see the new folder and the images as promised. Let's have a look. Great, so now you guys know how to run a web scraper using Docker in Lambda. And if you found this useful, again, I'd really appreciate a like and subscribe to this channel. But yeah, that's it for now. Good luck and happy web scraping. One final thing actually is if you ever need the GitHub repo for all this code and this project, you can find it right here across on the screen. Cheers guys, take care.